Good morning, everybody, and thank you for joining us today for today's JKMRC Friday seminar. My name is Nathan Fox from the W.H. Bryan Mining and Geology Research Centre here at the University of Queensland. On behalf of the SMI and the University of Queensland, based here in Brisbane, we'd like to acknowledge the traditional owners and their custodianships of the land on which we meet today. We pay our respects to their ancestors and to their descendants who continue cultural and spiritual connections to country, and we recognise their valuable contribution to Australian and global society. So it's a pleasure today to introduce today's speaker, Heath Arvidson, who's the Chief Geoscientist at K2Fly. Heath's a mining geoscience professional with more than 30 years experience in the mining sector. This includes more than 10 years working in gold and iron ores in WA and 10 years with BHP. He's worked across multiple commodities and global locations and has held senior management roles both at Golder and Anglo-American. He's known globally for his work in the mine value chain reconciliation, and he has technical strength in resource estimation and ore control practice. He's an experienced change agent and critically is able to effectively collaborate across different groups, from operations all the way down to the boardroom. Heath is a thought leader, and he's aiming to assist the mining industry to be a more transparent and sustainable industry. Heath joined K2Fly in 2020 as Chief Geoscientist, and K2Fly provide cloud solutions to leading mining companies across 54 countries to deliver ESG functions. So today's talk is an exciting concept, the self-learning ore body, or Slob. I think, therefore I am. So I'm going to hand over to Heath to start his seminar. I'm just going to stop this. Okay, Heath, over to you if you're ready to share your screen.
Thanks, Nathan. Welcome, everybody. Thanks for the opportunity, actually, to speak to you today. What I've got is really an overview piece about a vision for a slob. I'll just get this going. So pretty informal session today. We've got plenty of time. I'll probably talk for about 30 minutes. So we've got plenty of time for Q&A afterwards, which I invite you to join in. But what is a slob? I think this idea has been forming in my mind right throughout my career, I guess. I was just reminiscing this morning an experience at the first mine I worked at, which was the Sons of Gaulia mine in Leonora here in WA. It's a gold mine, a very old gold mine, where I was the spectral analyzer. I used to sit on the catwalk next to the operator on an excavator. He'd have the door open, a cigarette in his mouth, and I'd sit next to him and I'd say, okay, I reckon that truck's high grade. Send it to the crusher. That one, no, we've got a bit of waste in that one. That's going to be, marginal. So send it to the stockpile. So, from that point to this point, things have changed substantially. And I hope you get a feel for that through this talk. I think there are some similar concepts and terms out there that get bandied about these days that kind of similar to a slob. One is digital twin. And I think most people intuitively get that, that digital twin is a virtual representation of the mine. And people are attracted to this idea because of the rise in remote operation centres. So they want to be able to have this virtual representation of the mine, be able to see what's happening in the mine, where the equipment is, et cetera, et cetera. So that's all well and good, digital twin. Another term is a smart mine, which implies that there's something smarter, that there's new technology, that there's a mine that's enabled somehow more than it was before, but not very specific. And I kind of like self-learning ore body because it gets to a purpose. And the purpose that I'm envisaging is that as we mine, we continually learn every shift, every day. We're getting information coming from all sorts of different sources, and we should be able to use that information to continuously update the model that we have of the ore body that we use to plan all the activities in the mine. And I'll define a bit better. I'll paint a picture for you about what I think a slob is in a little while. But first, I'll go through the talk today. It's pretty simple. I want to talk about why, because I think that helps us frame why what are we talking about this for? What advantages, what value do we see, or do I see in a slob? I'll paint that picture. I'll tell you what I think a slob is, and then I'll go through a set of ingredients that I think are converging or arising at the moment that can actually make the slob a reality. We're moving closer to the slob. I want to talk about people quite a bit today because that's incredibly important to making things happen. So who cares? Who's impacted? Who cares about a slob? There's obviously some big challenges because in my experience, and I haven't been everywhere and I don't know everything, but I've been to a lot of mines. And as far as I know, there is not, the slob is not fully landed yet because there are some significant challenges, and I'll touch on a few of those. And then I'll just wrap up with a few conclusions and we can get stuck into those interesting questions that you're going to throw at me. Okay, so why? Why do I think people should desire a slob? Well, the first point is there's a real push in the industry to get people out of the mine. And 10 years ago, I thought that was a bit dumb because how can I do my job as a mining geologist if I can't go into the mine, if I can't stop the digger, walk up to the mining face, have a really good look at it, make a sketch map, pick the rocks up, feel how heavy they are, look at the minerals in the rocks. How can we run a mine if I can't do that? Surely that's just going to make it a dumb mine, not a smart mine. But I'm changing my tune, and I'm starting to see with new technology that the role of the mining geologist can more realistically be done remotely. And therefore, we can get people out of the mine and it will be safer. So that is a big benefit and a big advantage of the way this technology is moving, because there's a long history of people being killed and maimed and injured in mines, and it doesn't have to be that way. The second point here is about cost and revenue, obviously big drivers. And if a slob is realised, I believe we will be able to mine more precisely, more accurately. Therefore, there's less dilution and ore loss, less waste rock going into a processing plant, and therefore we'll have less cost and increase the revenue. We'll recover more of the metal or the product that we're chasing if we can mine more precisely. There's an aspect of ore control that I'll talk about a bit more, but I think if people embrace the idea that they can and should get more granularity and more confidence in their short-term planning and take it from 6 weeks to 18 months or 12 months to have that high confidence information, then what happens is your operation becomes more stable, more sustainable. You get the opportunity to create better plans that are more realistic and achievable. And by having a more stable operation, it's safer and it's more profitable. The next one here is about efficiency and speed, empowering people. What I've seen in my career and what I've done in my career is a lot of what I call hack work. There's a lot of effort and time that goes into collecting data, making sure you understand the quality of the data, interpreting, using mine planning software and geological software to build models in very, very manual ways. And what I see today is that there's real opportunity to automate a lot of that hack work. And if we do that, then the implication is that people are not spending their time making sure they've got the right decimal points or chasing outliers in their data set. They're actually able now to make decisions and to ask questions and to explore those questions and to do that in greater depth because they've got more time to do it. So I really think that's an important point about the slob. Next one, very important as well, a more transparent value chain, easier and quicker to see the risks and opportunities. And this is why we do mining reconciliation, actually. We want to understand what is actually happening through the mining and processing activities and understand and relate that back to the models that we've built of the geology and the ore body. And, a lot of companies do that once a year at the moment. And that probably sounds crazy to people, but that's true. Most companies probably look at that sort of information monthly. But I think even monthly, you know, you've mined X million tonnes in a month potentially, and then at the end of the month you say, oh, geez, I wish I'd known that, you know, in week one. So one of the benefits of the Slob, I think, is that we should be able to get the frequency of information down to a shift level. Why not? We should be able to do that. And if we can do that, we're going to see where our models are wrong. We're going to see where the opportunities are, and we'll be able to react in a time frame that we can actually capitalise on those opportunities. Technical assurance. This is a dirty word to a lot of people, particularly operators. They think it's an overhead and a burden, but this is really, really important. This is a hot topic today because there have been some real disasters in mining, and there is an increasing level of scrutiny on mines to demonstrate that they're doing what they said they would do and that they're operating in a responsible manner. And I think that another aspect of the Slob is that we can build in workflows and data tracking systems so that we know who did what, when, with what data. And so we can now discover why a decision was made and then assess the veracity of that decision. So, and that doesn't necessarily have to be an overhead and a burden from an administrative point of view, because we can systematise a lot of that stuff. So I think that's another real benefit of the Slob. I think, you know, it leads to more confidence in the results and decisions, both within the company and from a public point. And the other thing that's changed is that the technology is becoming more and more affordable. You know, mining's been going gangbusters for a while now, and so there's money there to spend, and mining companies know that they need to become more efficient and more effective. You know, this story about ore bodies and declining grades, we need to make more of what we've got. And, you know, things like sensing and scanning technology, tracking technology, the change in computer architecture and capability and mobility, moving to the cloud, moving away from proprietary data formats, exploiting algorithms, being able to really throw some computing power at algorithms to attack problems on a scale that we've never seen before. Similarly with optimization, we can do more and better optimizations because the technology is available and it's more affordable. So that gives me hope that we'll realise a Slob, and I'll talk a bit more about that. So those are some reasons that I think people should desire a Slob. Okay, so what the hell am I talking about? What is a self-learning ore body? I'm going to paint this picture on the basis of a value chain. So this is just a generic value chain. You could apply it to almost any mine, I think. And what happens is up front, we drill, we explore, we sample, we map, we do some remote sensing, we gather information, and then we build a model. We build a model of what's in the ground. And then a planning engineer will make an assessment of the mining method, make assumptions about ore losses and dilution and process plant recoveries and other factors. There'll be society factors, environmental factors that need to be taken into consideration, and ultimately land at a plan. And those first three steps happen all through the life cycle of a mine. And then we get into operation and we start doing drill and blast. We break the rocks. We get in there, we dig them up and we haul them to a destination. We've got stockpiles. We've got a crusher. The rocks go through that process into some sort of mineral processing or beneficiation. And you know, some of the material that goes into a process plant, the minority usually comes out as a product and gets shipped to a customer, and the rest of it goes into a waste storage facility or tailings. So that's the generic value chain. And up front, this process happens all the time. It's going on through the whole life of mine. We get more information all the time. We update models. We redo the plans. And it goes over and over again at different time horizons. You know, there's a life of mine plan, there'll be a medium-term plan and a short-term plan. Currently, that's quite a laborious process, and updates to models may only happen once a year for a resource model. And that's just not quick enough, in my opinion, and we should be able to do a lot better than that. So what I'm seeing in this process, from drill and blast to shipping, that's very linear. It's not iterative like the front end. It's very linear, and that's because you can only mine the rocks once. But these days we're getting heaps more information than we ever have before from each of these processes. So in the drill and blast space, we're seeing information coming from drill rigs, measurements while drilling that tell us about some physical properties of the rocks. I think penetration rates and other information coming off the machine. We can combine that with other data and infer things like hardness and texture of rocks. We've got information about blast movement. We've got information about fragmentation distributions. And those things, again, tell us something about the rocks and the nature of the rocks, how the rocks are responding to being blown up. We've got things like geophysical logging now in blast holes. We've got geological logging. We take samples. We end up with a set of qualities about the rocks. And what I mean by quality is not just percent copper. It's not just grade. It's all that other information. It's the physical properties. We can, with scanning technology, we can start to see minerals and textures. And so we're really starting to understand the rocks at a much deeper level and starting to be able to carry that through the process. Okay, so we break the rocks. We get a bunch of information. Then we start mining and hauling, and we've got, most mines now have fleet management systems, and these systems offer us a real golden opportunity aside from their main purpose. And their main purpose is usually to optimise the utilisation of equipment. They're used to manage the trucking and where the trucks are going and how they're timed against what's happening with the digger. But what's also happening in these systems is there's a location where rocks were mined. So we know where the rock was mined. We've got characteristics attached to that truckload of rocks from an ore control model, for example. And then we know where that material was sent to and where it was dumped. So we can actually track that material from in situ, and that's where we modelled it in situ, and then it goes into some other process. It either goes into the crusher or onto a stockpile. So those qualities can now be spatially tracked as we mined it, and stockpiles are a really interesting topic to talk about. Not many people get excited about stockpiles, but I do, because what I've seen and what still happens today is that we do all this work up front and we define a proven reserve. Then we go and mine that reserve, and a lot of it ends up on a stockpile. I haven't been on a single mine where there aren't stockpiles. There's some proportion of what's mined goes to a stockpile on every mine on the planet. And some of them, that's very significant because stockpiling, one of the uses of stockpiling is to blend materials to achieve a desired feed to a process plant. But what's been happening is that we build these stockpiles and we assign an average grade to the whole pile. And if that pile is consumed in the one shift, and that's probably not a big deal, but that doesn't happen. Some of these stockpiles are huge, millions of tons, and it's all given the one quality information, an average quality for the whole pile. And that's not actually that useful, because when I come and reclaim that pile, the truckload that I dig off that pile and send to the crusher is not going to have the average qualities. Ore bodies aren't homogeneous. And so using the fleet management system data, we can actually build a three-dimensional block model of a stockpile and assign qualities to locations in space and it's just an ore body model above ground. And then a planning engineer has got some granularity to start optimising what's reclaimed from that stockpile, blend it with maybe some direct feed or material from other stockpiles, and get much closer to the desired constitution of feed to the process plant that maximises recovery and process performance. So that is starting to happen I have seen some really good work in that space recently, and it is starting to happen in one of the mining companies I've been working with, and it's incredibly valuable. And I think it's the other effect of being able to do that is that you make the reconciliation results less ambiguous. If I've got 40% of the feed to my plant coming from a stockpile and I've just got one average number assigned to it, I've basically lost control of the material. You know, my proven reserve, and this happens, this is ironic, but it happens. A proven reserve is mined, goes onto a stockpile, and then it's reported publicly as an indicated resource. We've lost confidence in what's in that pile. It's not only ironic, it's moronic. It doesn't have to be that way. We can track it, we can build models and retain some confidence. Okay, so that's enough of a rant about stockpiles. We end up with rocks going through a crusher. And again, we've got scanners, we've got sensors, we've got weightometers. We're getting more information as the rocks go through that crusher and head towards the plant. But we're also now getting information like power consumption, water consumption. It goes into a process plant. We get even more information about what's happening, you know, use of reagents, for example. And we're also tracking qualities as we go through these processes. And that's golden information, you know. And then we end up with products going to customers. But what is it that ties all this together? Well, it's the mine value chain reconciliation. All this information is available, and the reconciliation process involves comparing our models, our predictions, against what actually happens in the mine and what actually happens in the process plant. And if I can relate all those outcomes back to my prediction spatially, then I can really understand how the ore body is responding to those processes, and therefore I can improve my predictions of what's going to happen to similar rocks that go through the process in the future. And that's really the key here. You know, if I can predict that a block in the ground will be mined and will take, you know, X kilowatt hours to process, will consume so much water and so many reagents, and if I get that prediction, you know, really precise and accurate, then this whole process is going to be much more stable, much more predictable, and much more profitable. So how do we do that? Well, this is where my expertise runs out a little bit. Shazam, well, how's all that information tied together and fed back to update the model? Well, there's some heavy and amazing automated mathematics available to us now because of those changes in computing that I alluded to earlier. You know, things like machine learning, which has actually been around for a long time, is now coming to the fore because we can actually apply enough computing power to make it work in real time. And so also there's some clever geostatisticians out there who figured out how to look at these spatially located pieces of information and correlate it back to the ore control model and update the ore control model. So I want you to imagine that this is a reality. And if we've got a mine like this, we've got a self-learning ore body, and all these data sources are working all the time, every day, every shift, every hour, giving us information. We should be able to update our ore control model on a shift-by-shift basis. And therefore, our predictions 12 months, 18 months out are always improving, always becoming more accurate and more precise. That's the dream of the Slob. Okay, so how would we make all that happen? That's quite an ambitious vision right there. Okay, so the first thing is people. We need to address the people and change management challenges. We can get excited about technology, and we do, and we spend a lot of money on trialing technology and putting it in place. And sometimes we leave people behind. We don't spend the time to make sure that the people impacted by that change understand why it's happening and how to deal with it and how to make the most of it, how to imagine themselves still being useful and valuable in this future world. And that's a key challenge. I'll talk a little bit more about that later on. And it's just critical. You can't progress without addressing those challenges. The second 2 points kind of work together, but there's a real shift going on in the industry where companies are wanting to get away from proprietary data systems and desktop applications. They really want and see value in having systems that are agnostic to other systems. They need to be open. They need to be easily able to be integrated and talk to each other. So, the idea is that you have a data environment and you plug in applications to solve specific problems rather than relying on one platform that does some things really well and other things really poorly. So that's the paradigm that's being broken at the moment, and it's been broken because these systems are now moving to web-based systems and software as a service. And what that means is you can scale up the performance of that system by expanding your farm of servers and throwing more computing power at it. And also, in that model, you don't need to update software on 4,000 individual personal computers for your people working on the mine. It's accessible through a web interface. So that's a paradigm shift. It's a really important enabler for the slob. And that data environment needs to have spatial data coupled with temporal data. So, getting back to all that information coming from the value chain, it's time-stamped and needs to be coupled with where it came from in the ore body for us to make our predictions better, for us to really exploit the correlations between different types of data and build it back into our ore control model. I mentioned the hack work. There are significant opportunities to automate the hack work. There's algorithmic approaches that we can now really throw at some of the processes that have always been done manually. A good example here is designing ore blocks. So that there are tools out there now where you can automate the design of ore blocks using an optimization engine. It's a bit like, for those of you who know about pit optimization, the Whittle system. It's a bit like Whittle for ore control. And if you think about it in the context of I spoke about 12 to 18 months ahead of mining. Okay, so if I put the effort in and I get all the information I need 12 to 18 months ahead of mining, now I can design ore blocks for a bench, a whole bench, or a couple of benches. And I can do that with a certain set of parameters and constraints and get a certain outcome. And then I can change those parameters and constraints and run scenarios. So now I've got a set of potential dig block designs for 12 to 18 months ahead of mining. And what that means is I can do that really quickly. I can iterate it. I can run it through the planning process and see the outcomes. I can see where there's uncertainty. And I can, if I need to, I've got the opportunity to go and get more information and plug the gaps. So that's a really powerful approach to doing ore control. And I think if you want to do it that way, and I see enormous value in doing it that way, I think you have to automate that dig block design process. I mean, when you come to mining, you're going to have a bit more information, so you can always update it. But I was working with a company recently, and they're moving in this direction. They understand that they need to be blocking out on a bench by bench basis, so they can optimise the drill and blast and load and haul much better than they have been. But for one blast, and a whole bench might have 40 or 50 blasts, just for one blast, it took a geologist a week to do a dig block design for that one blast. So for them to realise their dream of having a bench worth of dig block designs, they had to automate it. There was no other option, really. There's other things like in reconciliation, one of the pieces of work we have to do is we have to deplete our models so that we can extract the material that's been mined from our model and compare the prediction from that model to what actually happened. And that process is done pretty manually. Usually at the moment, people will use Vulkan or Datamine, and they'll get a wireframe topography surface from their survey friends and manually go through a process to extract the model cells within two surfaces. That can be automated. That can take days and days of work. Let's automate it. We can do that now. So, and there's many other examples, I think. And all that, by automating those things, we can give people time back to think about the right questions. The next point here is feeding the right people with the right information at the right time to make decisions. Systems today offer us automated workflows and ways to connect people with information according to a schedule of events. And that's really powerful. And what it does is it frees them up from, first they have to remember what they've got to do, then they've got to go and find the data, then they've got to make sure the data is the right data, that they haven't got uncertainty. And then they get 4 minutes at the end to make a decision. We can, again, there's an automation piece that we can do here to connect people and information at the right time and give them enough time to make the right decision. Continuous feedback and communication, as I said, reconciliation and this previous point about workflows, really breaks down the silos. If you're doing all these processes, if you're doing the ore control modelling, the dig block design, the short-term schedule, the surveying, the mineral processing, if you're doing it in silos, then people aren't communicating effectively. And I've seen this time and time again. It's so frustrating. Where, even mapping the value chain, I've done this exercise so many times, and you get in a room and you finally get everybody in the one room, and the geologist says, "Oh, this is how it works. This is how the value chain works," and the processing guy says, "No, it isn't. It doesn't happen that way at all. It happens like this." And after a bit of argy-bargy talking around the table, we finally get to an agreement on what the value chain is. So, we can't take that for granted that people have effective communication. So by using this system approach, we can improve that. We can make it much more effective, in my opinion. So I think that set of ingredients gets us a lot closer to realising the slob. Who cares? Again, people. Well, I mentioned before, technical professionals. Let's get them away from the hack work. And I understand some professionals really enjoy that hack work. I'm not having a dig at those people. That's essential work at the moment without these systems. And even we need people who think that way to support these systems. But I want the frontline technical professionals in the mine should be focused on the decisions and the continuous improvement. They need to be able to see what's going on and get to sound conclusions about how to improve it. I think managers should be very keen on the slob, to be able to see performance in real time, to better optimise future performance. Again, with workflows, there's notifications, so we can set up triggers when certain events happen or certain processes go outside of a tolerance that we think is a warning sign. We can raise notifications when it happens at the time, and then they can focus their attention on it. They'll be able to demonstrate value add because all the information flows are tracked, all the decisions are tracked, and then they can reconcile much more accurately. They can reconcile with much less ambiguity and really show the value that their continuous improvement is adding to the process. And they can show technical assurance. They can give their management, they can give their shareholders and stakeholders much more confidence that the decisions that have been made in the mine were based on sound information and sound decision making. They'll be able to demonstrate that. And ultimately, this leads to more stable and predictable operations. And all the stakeholders really want that, and the regulators want that. And by having that technical assurance, you're in a much better position to explain your environmental, social and governance performance to anybody who's interested. And that is a hot topic. Everybody involved in mining is really getting super focused on this ESG piece because we have a terrible reputation in mining and people don't trust us. So they're going to ask us to demonstrate our performance. And I think that's okay. That's good. Okay, now there are some significant challenges. The first one is, I hope I've been quite persuasive today and I've got you all sold on the value proposition here, but that's not actually very easy in a mining company, in a mining environment. There's always lots of improvement projects being proposed and undertaken. And sometimes, the connections between those projects are difficult to see and difficult to understand. And this is one of the great benefits to a digital twin, in my opinion, is that you can propose an improvement and then run it in a virtual model and see what the implications are before you actually do it in reality. And that really helps to show a value proposition for an initiative. A coordinated organisation. This is taken for granted, but it takes a lot of effort and a lot of strong leadership to have everybody understanding the same vision and the same plan to get to that vision. It's not a simple thing to have a coordinated organisation. It starts with a strategy, it starts with values that guide how people work together, and that takes a lot of effort to set up and maintain. Change management is often poorly done in mines because it's a very fast-paced environment, and people just want to get the job done and get the rocks into the plant and move on. And change management involves, you've got to make everybody aware of the benefit of a proposed change. You've got to get them to desire that change, and that's not a trivial task. People will question it, and it takes time to go through that process and get them to really understand why a change is important and valuable. And then you've got to make sure they've got the knowledge about how to change and the ability to change, the resources and the tools. And you've got to reinforce that change. You've got to always come back and make sure that it's being done in the right way and that people are still working in the same direction and working together, being coordinated. So those 3 points about people and understanding what a change means, in my experience, those are the biggest inhibitors to change and to moving forward and to implementing technology in mining. The last point, also non-trivial, but getting easier, is the integration and sustainability of the technology. And the thing that's making this easier is that shift to the cloud, the shift to software as a service, open architectures, open data systems, that will lead to more integration and make it easier to sustain that sort of environment. So it's not trivial, but it's probably less of a challenge these days compared to these other things, in my opinion. Okay, so just to wrap up, we've eaten the pizza. We're going to have safer, stable, more sustainable operations with a slob. The value is significant. Even just in doing manual reconciliation, there's huge value that I've seen. But it's not just about dollars, it's about this ESG piece. Really, really hot topic. It's having a massive impact on the industry. The technology is there, it's available, but change is hard work. And you've got to be focused on change and understand the science of change management to really be successful. So I hope you've enjoyed that overview of the slob, and I'm looking forward to some Q&A.
Okay, excellent. Thank you so much, Heath. I think it was a really exciting concept, and hopefully, I don't know how long it's going to take to implement, but hopefully in the next sort of 5 to 10 years, we see some positive case studies that actually show this full-scale integration. Hopefully, we're not too far away. We probably can't allude on exact case studies, but hopefully there are companies there that are pushing this along.
It definitely is, particularly the major companies, because they've got the resources and they've got the operations that will benefit hugely from even a 1%, 2%, 3% improvement in their processes. So parts of the slob exist today. So it's a matter of really getting it from end to end. That's what's needed at the moment. It's one of the things I'm pursuing with K2Fly. If we did it in 5 years, I'd be astounded. I think within 10 years, it's probably more realistic.
Excellent. Well, if for those of you online, if you have questions for Heath, please type in the Q&A box. If we have any questions in the room, anybody wants to comment or ask any questions directly to Heath, or yeah, we've got one question over here.
G'day, Heath. You talk about removing the geos from the the coalface, as it were. With the anecdotal evidence we hear from various places and universities that are no longer doing field work, no longer doing structural training, and you've pulled geos out of the field, and that is basically where geos learn to be geologists. It's in the field looking at the rocks. So how would your Slob process solve these dilemmas?
That's a really good question, and I don't know that I've got the answer, but I've had a few thoughts about this. So that action of pulling geos out of the mine is predicated on having sufficient and appropriate information to be able to do that. So we do need to be able to see structures. We do need to be able to see minerals. We need to get all the sorts of information that a geologist would get. But your point about how do you train a geologist to be a geologist, the analogy I've got is, I've been in what do they call them? It's training centres where they've replicated sections of a mine above ground. I'm thinking about an underground coal mine in South Africa that I worked at. They had built a pretend mine on the surface, and they would train their operators and people in that environment, which was inherently safer than the real thing, right? So I think something like that is a possibility for training geologists. So they still get exposure to being at the mine face. They still get in an environment where they've got to think about the right things, and they've got to be able to identify the things to look for. So that's all I can offer at this stage, and I think that's a really important question. Thanks.
I have a kind of a quick question just about the adoption of technology. From your experience, you mentioned you worked in a coal mine. I get the impression that fields like oil and gas and coal have adopted much more quickly to targeted technology that answers their specific questions. In the mining sector, we seem slower to adopt technology. Is it because when you think about a hydrothermal deposit, we have a much larger amount of variables that we have to try and measure, or are we just, as an industry, slower or reluctant to adopt the technology that we can actually use to implement this change?
It's a really good question, Nathan, and it's a bit of a generalisation, I think. I've got examples in my mind of coal mines that have done really great stuff implementing technology, and I've got examples in my mind of platinum mine that's done really well, copper mine that's done really well, other mines in both hard and soft rock that have done really poorly as well. I mean, there is a conception out there that coal is a bit simpler, but I don't buy that, because the aspects of geometallurgy involved in producing a coal product are really quite complex, and the processes involved in getting information to predict outcomes for coal deposits is quite complex. Yes, some polymetallic deposits are very, very complicated mineralogy, and the processing route is really complicated. And so if you've got something like that, it is difficult to make change. So I think there's a few issues involved in that observation. Maybe you could tell me a bit more about the types of technology. Maybe there's a difference in the types of technology that have been adopted in coal versus hard rock mining.
I'm not the most informed, but I guess I had this conversation with somebody who was kind of involved in the early development of the hyperspectral scanners, and 25 years in the making, they're only really now being uptaken by the mineral sector properly. And I'm just trying to understand those barriers to that uptake is hard. And this particular person just drew a comparison, I guess, to the oil and gas industry, where they seemed much more targeted in their question that they were trying to find a technology to solve, whereas in the mineral sector, maybe we generate technology that creates a lot of interesting data, but we're still trying to piece that back into the picture as to how we actually use that data to solve our problem. And I think maybe that's probably, I guess, why I was going with that kind of comment.
One of my observations about the difference between oil and gas and minerals is that if you decide to do a project in minerals and you come up with a budget, If you wanted to do a very similar project in oil and gas, what you need to do is add 3 zeros on the end of the cost. They've just had more resources, more money, and I think that's part of the answer to that observation. But yes, hyperspectral scanning is not new. It's been around, as you said, 25 years thereabouts. Measure while drilling has been around since the 50s, and is only now just starting to be implemented really in mines, including coal mines. So there's a few other. Machine learning I mentioned, that's been around for a long time. The concepts and approaches to machine learning have been around for a long time. Change takes a lot of time, takes a lot of effort. And I think, a lot of people think they can skirt around the side of that, but it just doesn't work.
Just on the subject of machine learning, we just had a question come in from Rob Chatterjee. He's a PhD student here. He's kind of deep in the machine learning world. And he just asked the question, do you see the machine learning solutions being implemented internally within the mining company, given that the data sits across silos, or by an external consulting group, or maybe both?
I'm seeing both, definitely. I've seen, large companies have built their own data analytics teams and bought in-house capability in that space and custom build solutions. But there's also some really interesting boutique companies out there doing targeted solutions, and companies will outsource to them to provide the solution. And I think as long as we've got that data platform and it's open and agnostic, then both approaches can work and be sustainable.
Excellent. Any comments, questions? We've got a question or comment from Tim.
Hi, it's Tim Napier-Munn here. I really enjoyed that talk. It's a new idea. I'm not sure if an advertising company would agree that slob is a great term to give something you want to sell, but it certainly gets attention. I liked your emphasis on stockpiles. I think they're the Cinderella of the value chain, and they are really important, and they do complicate things, and we generally ignore them. There's some great work going on here. I'm not sure if you're aware of it, in the modelling of a stockpile as a processing unit, because, of course, they segregate by size, and that has a big effect. So if you can model that, you're 3/4 of the way there to the problem. So I think that's an area that you rightly say needs attention and is getting some attention. Question, it's a kind of bit of a left field thing. You emphasised the importance of the whole information technology part of this idea. So the move to cloud computing, open architecture, open databases and so on. You seeing any nervousness about security in that area? The hacking that we've seen, not just grabbing information, but bringing down whole operations by people who really want to do nasty things to our way of life. Any comment on that?
There's huge anxiety about that in companies, and usually when we put some of our software as a service solutions into these companies, it's done in a way that's called on-premise. So it's actually a cloud system that they built internally and they control. It's not an open or it's got the security built around it, because the last thing these companies want is for people to get into their information and systems and disrupt them. That's unacceptable. So that's a very, very good point.
Thanks very much. Well, that's good. I think that was a good question. I guess I have kind of a question about that, just about the, I think there's security and certainly stopping, like Tim mentioned, hackers bringing down operations. But in terms of the sector as a whole, do we want to succeed together, or is there still this competitive advantage kind of strategization between the major companies where they want to be better than the other, or should we be more open about the way this could work, so that as a whole sector it kind of improves together as opposed to...
Yeah, that's a good question, Nathan, and I've got a few reflections on that. One is I joined BHP Iron Ore in 2002 and went to live in Newman in the Pilbara. I was a resource geologist at Mount Whaleback, and at that time we used to have collaborative technical sessions with Rio Tinto. the geologists would get together and we'd share what we were doing, and we'd learn from each other, and then go and have a barbecue and a few beers. And it was really productive and valuable. But once the boom took off, in 2002, the iron ore price was about $20. Both Rio Tinto and BHP were marginal producers. We were looking at raising the cut-off grade in Mount Whaleback to 64% iron just to be profitable. So that was a very different environment. Once the boom took off, that changed. And then around 2007, 2008, BHP tried to take over Rio Tinto Iron Ore. So it was, daggers drawn and all the rest of it. I think now what I'm seeing is the push on ESG is getting companies to work together through groups like the ICMM. The smart movers have realised that there's some issues that we just have to work together on to improve the industry, and we have to improve the industry because it could become unviable. It could it's got a bad reputation, and that we have to improve that to be successful. So that's one area where companies are really starting to collaborate and work together. Interestingly, another one is one of the things I do is I run a forum. It's a resource reserve reporting forum, and it's made up of vice president level geoscientists and others in mining companies, some consultants, and they're not all customers of ours. We've got other companies involved in this, and the intent is that it's a bit of a think tank about resource and reserve reporting around the world. So what's the landscape look like? What's changing? How do the different companies approach the public reporting of their portfolios? And they're all motivated to be part of that, because the public reporting of resources and reserves is another area where reputational risk is what they're trying to avoid, and they want to be able to do that work in the best possible way they can. So they're really interested to understand how others are doing it. And there's been some really nice collaborations come out of that forum, and papers written. We've just put together a paper on reporting mineral resources exclusive of reserves, and that was spurred by a change in the rules in the United States, the introduction of SK 1300, which has brought the rules in the United States into line with the rest of the world, more or less. There are some curly differences in there. So that's a really good industry collaborative forum where people are working together. So there are some good examples of that. And I think that reflects the general mood. That's what I'm seeing in the industry is, but it is all hands on deck for some of these issues.
Thank you. That's a good issue, I suppose, from us as a kind of a research institute to some degree. There's also the collaborative research projects that get carried out particularly around Australia, but often involving global companies. So I think it's good to see companies participate in those and seeing this kind of transparency in data and knowledge. And I think that's really key as well.
Absolutely. The CRCs are fantastic. I was involved in CRC ore representing Anglo-American for some time, and there were some fantastic projects that came out of that. Really awesome.
Yeah, no, that's really key. We've got one more question just from Henry Kurth, naturally about sensors. He's talking about how sensors are going to be used increasingly to automate grade control once material has been blasted and removed. And he's asking if you can just comment on how that's going to affect the role of the geologist or the grade control geologist specifically, and how well that's going to be kind of accepted by the industry in this sort of transition to more automation and scanning technology.
Yeah, so that might be alluding to things like bucket-mounted XRF and hyperspectral scanners, that sort of thing, which could give us truck-by-truck information on qualities of the ore. How is that going to impact the role of the mine geologist? I think it just adds more information for them to consider in the process. I think it potentially helps get geologists out of the mine, because now we're seeing information coming directly from the mining face. I think it's yet to be proven, and it's yet to be understood how to incorporate that information sensibly into the overall information flow back to updating an ore control model. I think we'll get there. But a mining environment is a very harsh environment. It's very difficult to have robust enough equipment to be able to sense that and to be able to maintain the calibration of those sorts of gadgets. So, I'm not painting a very clear picture about the impact on the geologist there, but I think all of these technologies mean that the role of the geologist actually becomes more important, because you still need someone thinking about what the information means. You've got to have someone there who can relate that information to the knowledge of the ore body, because sometimes those sensors and machines do become uncalibrated and they start spewing rubbish into the system, and we've got to be able to pick that up somehow. So we need people who can relate back to the ore body.
Absolutely. That's good. We see that uptake of ore deposit knowledge groups as well, which I suppose hopefully are kind of sitting above those silos to try and help bring different groups together and understand that value. So
yep.
That's a great change that we're seeing. So I think we're kind of bring it to a close. Heath, you might be able to see in the chat box there, but there's a comment from Andrew McCulloch just complimenting your talk and just highlighting again that the human change aspect is critical, and as an industry that we need to move to be more open and share our learnings, our data more widely. And I think that's a really important message as well. So we didn't give you a round of applause, so maybe now for us in the room, if we can just give Heath a quick round of applause.
Thanks very much.
I'm just going to quickly advertise next week's talk if I can. Hopefully you can see that. So next week, it's quite an exciting session. We've finally got a JKMRC speaker, and Vladimir Djokovic, who's a senior research fellow here, is going to be talking about the influence of ore blending on mill throughput. And they've got a great case study from the Cortez mine. So looking forward, hopefully, for you to join us then. And you can join us online. The SMI events page holds all of the links. But failing that, you can also wait for us to send out the email as well. Okay, well, thanks again, Heath. It's been really, really good having you online today and joining us from Perth. So thanks again, great presentation. And for those of you that are interested, hopefully you don't mind, we'll make the recording available online as well as a YouTube video, which is available on, I think we have a JKMRC YouTube channel where all of our seminars get posted. So
perfect. Thanks, Nathan. Great. Thanks for the opportunity, and thanks for everybody for engaging.
Great. Thank you again. Cheers.
Cheers. Bye, everybody.
Bye.